Okay, so today we're going to be talking about simplifying rational expressions as well as multiplying and dividing rational expressions. What a rational expression is it's basically, for example, let's say x plus 2 over 3x plus 4. That's a rational expression. Fractions, okay? We're going to learn how to factor and simplify very quickly. You guys ready? Okay. Next page. So a rational expression is in simplest form when it can be factored no further and nothing else simplifies out. Okay, it can't be factored anymore and nothing else cancels. Got it? So it can no longer be factored and nothing else cancels. So let's look at some differences between some that are in simplest form and some that aren't in simplest form. First one I have up here is x over x minus 1. This is in simplest form. Why? Because I can't factor it any further than it already is, and nothing cancels out here. How many of you, when you first saw this, wanted to do this? Anybody? I know some of you did, but we'll pretend like you didn't. So here's my reasoning behind it. Is 5 over 4, does this cancel? No, absolutely not, right? This is the quantity x, this is the quantity x minus 1. This means one less than the one above it. Are they the same thing? No, so they don't cancel. Ms. Newtown says they're married, right? Sure, just don't cancel. Got it? 2 over x squared plus 3, does it factor any further? Does anything cancel? It's in simplest form. Okay. So a little bit further down, we have some that are not in simplest form. I have x over x squared. Why isn't that in simplest form? Yeah, I've got 1x in the numerator, 2 in the denominator. What would happen here if I were to simplify it? Speak up. Where? On the bottom. Give me a word for bottom, please. Denominator, yeah. This would simplify out to be 1 over x. Okay, I have 1x in the numerator, 2 in the denominator. One set would cancel out, and you would get 1 over x. So that would be in simplest form if I were to reduce it. Its current form is not. The next piece, the next one, is what we call a complex fraction. We're going to be talking about those in depth over the next few days. Okay, we're not going to really get into that right now. But this is not in simplest form. It's ugly looking, right? Chances are, if it's ugly looking like that, it's not in simplest form. Okay? Next one over. Is that in simplest form? Why not? Thank you. X minus 3's cancel out, and I'm left with 2/3. Okay? So that one wasn't in simplest form either. So what we're going to be doing is we're going to be factoring and getting things into their simplest form. Are you guys ready? Okay. So let's look at my first example. I've got x squared plus 10x plus 25 over x squared plus 9x plus 20. So what do you automatically want to do as soon as you see this? We want to start by looking for a GCF. Sure. So if I look in the numerator, is there a GCF? No, I mean 1 would be a GCF, but that really doesn't do anything for us. What about in the denominator? Nope. So GCF isn't going to help us. What next? Let's factor. Okay, so let's start in the numerator. And we're going to factor this out. So I'm going to set up my two parentheses. I know I'm going to have x and x. Are my signs going to be the same or different? The same. You look here. If it's plus, they're the same. And what are they both going to be? What are the signs both going to be? Addition, right? So plus, plus. Okay, so I need two numbers that multiply to be 25 and add to be 10. 5 and 5. That was easy, right? Good. That's what we call a perfect square trinomial, by the way. And we'll get into that in depth a little bit later on this year. Okay, denominator. I know I'm going to start with x and x. Are my signs same or different? And they're both going to be addition. Two numbers that multiply to be 20 and add to be 9. 5 and 4. Great. Okay. What happens? X plus 5 cancel out. And I'm left with, that's it. So now there's one more thing on top of this that I want to talk about. We have x plus 5 over x plus 4. I want to talk about any restrictions that this rational expression has. Now what I mean by restriction is what values of x, value or values of x, would make that function undefined. What does undefined mean? I guess we need to go there. A little reminder. How do I know when a function is undefined? What happens? What equals 0? Something. What is it? No. Say it again. The denominator. Yeah, a function is undefined when the denominator is 0. This would be undefined. Okay? So I need to figure out what value of x right here would give me a restriction, meaning what value of x would make my function undefined. You guys are geniuses. Okay, so I know that x cannot equal -4. Why can't it equal -4? Because my function would be undefined if it did. Good. So that means this rational expression right here, this function, doesn't exist at the value of x equals -4. We get what's called a vertical asymptote, and we'll talk about that a little bit later on this year. Okay? We good? Not too bad so far, right? Okay. So I've got 3 on this slide. You guys are going to do these in your notebook. Okay, so let's start with the first one. We'll give you a little jump start. Now this one obviously isn't factoring, right? This one's just simplifying. So why don't you give that one a shot, and we'll go over it in a second, okay? Okay, so I heard a lot of things going around. I heard about when you divide variables, you subtract their exponents, right? I heard that. That's excellent. You're absolutely right. I've got -27 divided by 9. I know what that equals, right? What is it? -3. Where's that -3 going to go? Good. Okay, now, here's the trick to that one. We have -27 over 9. For those of you that did this, tell me why it's wrong. Wow. Why is that wrong, though? This is 1/3, right? You guys just got done telling me -27 divided by 9 is -3. Is this -3, this whole thing? No, it's -1/3. Okay, so think about where you're putting things. Okay, so you're right. It's going to go in that numerator. Okay, we got that far, right? Okay, so I have x cubed divided by x to the 4. I got to subtract those exponents, right? 3 minus 4? Yeah, -1. Goes in the bottom, but is it going to be negative? No. So you can think about it like this. I have 3 x's up here. I have 4 down here. That's what an exponent means. It means repeated multiplication, right? How many cancel? Where am I left with the 1? So if you need to do it that way, do it that way. What about the y's? So I'm left with -3 over x. Done. Are we okay? Is it coming back to you? Floodgates opening? 9th grade? Long time ago, right? Okay. Or 8th for some of you. I don't know. All right, so next one down. Go ahead and give it a shot. We'll go over it in a minute. Okay, so numerator, -6 minus 3x. What's the GCF? Yeah, I would say -3. And the reason I would want to pull out a negative is because do I generally like to be left with negatives in front of x's? No. So let's pull out a -3. What's going to go in those parentheses after I pull out a GCF and -3? Careful. Well, yes. 2 plus x. Is that the same as x plus 2? Sure, you could write it either way. But be careful. Is 2 minus x the same thing as x minus 2? No, so you have to be cautious when you're doing that. Okay, just keep that in mind. All right, denominator. Good, x minus 4, x minus 2. Excellent. Does anything cancel? Nope, you're done. Okay, so when you pull out a GCF, the way that you get this piece here is you take your original, right? And you divide each piece by what you're pulling out. Okay, -6 divided by 3 is +2. Got it? Okay, good. All right, try number 3. Okay, so the denominator you factor to be what? Good, excellent. No problems there. All right, so the numerator is a little bit more difficult, right? We have that leading coefficient of 2. Now, the first thing I would generally look for is a GCF, but since there's no number that divides into 2, 3, and 2, I can't pull anything out. So I have to go with what I have. So the way you always start that is you're going to have 2x and x. I know it's kind of funky looking. The board's a bit off. Okay, so you've got your 2x and x, because when I go to FOIL that back out, 2x times x is going to give me that first term of 2x squared, right? Okay, so the next rule that I have to follow is I need two numbers that multiply to be a negative 2. What are my options? Yeah, negative 1 and 2 or negative 2 and 1. My only options, right? When you have a leading coefficient other than 1, you cannot use the rule what adds to be 3, negative 3. Okay, you can't use that rule anymore. So we have to go by having your 2x and x and then your 2. So what you wind up doing is it's kind of like a guess and check. You shove them in there, you FOIL it out. If it doesn't work, you try the other group. FOIL it back out, see if it works. Okay? So the goal is to get my center terms when I FOIL to add up to be a negative 3x. Okay? Are my signs going to be same or different? Same or different? Same or different? Different. This is minus. Signs are going to be different. Okay? All right, now, do we want to try negative 1 and positive 2, or do we want to try, what do you want to do? Do you want to try negative 2, positive 1? Let's try it. I'm going to throw it in there. If it doesn't work, we're going to cross it out and try again. Okay, so let's FOIL. 2x squared times x is? Good. Did I just say 2x squared? I did. I'm sorry. My apologies. 2x times 1. Positive 1. Yeah, positive 2x. Negative 2x times x. Is that going to give me my center term of negative 3x? Do-over. That didn't work. Let's try again. Okay. How do you want to try it this time? We want to try negative 1 and 2? Negative 1, positive 2. Let's try it. 2x times x is? Okay. Negative 1 times x is? Negative x. And 2x times 2 is? Positive 4x. What's that going to give you? Positive 3x. We're close. We're really close. What's the problem? Yeah, let's make this positive and this over here negative. No. Okay? So if we do that, now we have positive 1x minus 4x. What's that give you? Negative 3x. So it's trial and error, guys. You just got to put them in, try them out. If they don't work, switch it up. Okay? So that works. So what happens now? Good. And I'm left with 2x plus 1 over x minus 3. No idea. Okay, so let's go a little bit further. We're going to do multiplication now. The nice thing about this is it's basically the same exact thing, except we add one extra step on the end. When we're multiplying rational expressions, your first step is going to be to factor everything you possibly can. Second step is to cancel everything out that you can. Then third step is to multiply. Okay? So when I have two fractions and I'm multiplying, where am I able to simplify? Or how, I guess? We know we can simplify up and down, right? How else can we simplify? What do you mean by across? Yep. Yeah, diagonally. Can you cancel side to side? No. If something is, if we have x plus 1 here and an x plus 1 here, you cannot cross those out. Okay, it has to be diagonally or up and down. Got it? Say yes. Yes. All right, so let's give this a shot. I have 2x squared plus 7x plus 3 over x minus 4, and x squared minus 16 over x squared plus 8x plus 15. We are going to factor everything humanly possible, and then we are going to simplify. Okay? So, where do you want to start? I always leave the hard stuff for last, so where do you want to start? Yeah, x squared minus 16 should be a quick, easy one, right? And I know x minus 4 is going to stay the same, so we'll leave that. What does x squared minus 16 factor to? Good, x minus 4, x plus 4. Just a little side note here. If I had 9x squared minus 25, how would that factor? Tell me what it is. Good. Good. You guys see how we got that? Back table? Back table? Okay, how about 16y squared minus 49? Careful. 4y, 7. Square root. Okay, difference of two perfect squares. Are we good? Excellent. Okay. Denominator, second fraction. Yep, x plus 3, x plus 5. Excellent. Multiplies to be 15, adds to be 8. How are we doing? Numerator, first fraction. Ugly, right? Let's work it out. Any GCF? So I know I have to have 2x and x. My sign's going to be the same or different? What are they both going to be? So that makes it a little bit easier, right? We don't have to worry about that. All right, what do these two numbers on the end have to equal when you multiply them? 3. So I know it's going to be 3 and 1. I just have to figure out where we want to put them, right? I know my center terms, when I FOIL this back out, need to be 7. Where do you think I should put the 3 and 1? Yeah, let's put the 3 here. Why? Yeah. Your end terms, right, first, outer, and last, these two here, this will give me 6x. That's pretty close to 7, right? My inside term, if I make this 1, will give me that 1. So here's 6. Here's my 1. Outside, inside. That'll add to give me my 7. See how this is 2x squared? Okay, so when I go through my FOILing, first, 2x times x is, so you have to have it there. Okay? Just like over here, you just have an x, or here, you just have an x. That's why we have x and x. Okay? All right, so now what happens, guys? What do I cancel? X minus 4. X plus 3. Anything else? Awesome. 2x plus 1 in the numerator times x plus 4 all over. Excellent. Okay, so let's try the next one. We didn't do the restrictions on the last page, and my notes are gone. Awesome. What was the last page? What was the answer? I'm sorry. Good. What's the restriction here? What can't x equal? -5. Good. You guys are good at that. Any questions there? Somebody just say why. Why? If I plug in -5 here, what happens to my denominator? 0. Can you have 0 in the denominator? Makes it undefined. Okay? Yes, that's it. Okay, so next one, I want you to go ahead and factor everything out, cancel, multiply, and then state your restriction, please. Okay? Restrictions or restriction. Go ahead and give it a shot. All right, so numerator, first fraction, a squared minus 4. How's it factor? Excellent. Denominator, first fraction, how's it factor? Excellent. Numerator, second fraction. Leave it alone. Denominator, second fraction. Good. A times the quantity a plus 2, GCF, right? What factors? Or what cancels, I'm sorry. Yeah. Good. Okay. A minus 2 in the numerator. Good. Let's talk restrictions. Okay, so 1, we know 1 is going to be 1 because if I put a 1 in here, 1 minus 1 is 0, right? 0 times anything is 0. What about this out here? What about this A? Would it be 1? Because 1 times 1 minus 1 is going to be 0. We've got 1. Who said that? Yeah, 0. Why 0? Yeah. 0 times 0 minus 1. Anything, 0 times anything is. So if you're not sure on how to get that restriction, why did I just do that? I don't know, because I'm special. Okay. If you're not sure how to get the restriction, the easiest way to get it is to take your denominator and set it equal to 0. Okay? And then solve that. This is already factored for you. So all you have to do from here is use that 0 product rule you guys learned about when you were solving quadratics in 9th grade. Okay? You've got a equals 0. There's your first restriction. Solve that. You got a equals 1. There's your second. Is that easier to find restrictions? Yeah. All right. We got one more thing to talk about. Are you ready? I know I'm going fast. Okay. So the last thing we're going to talk about is dividing. Guess what? Dividing is the same thing as multiplication, except we have one extra rule. How do you divide fractions? Yeah. Keep, change, flip, right? So we change division and multiplication. We flip the second fraction. And then we do exactly what we just did. Yep. So if this is a division sign, right, we keep the first fraction. We change division to multiplication, and we flip the second fraction. Did I say the first fraction? Say no. No, you only flip that second. You take the reciprocal of the second fraction. Okay, never the first. So all we did was keep, change, flip. Isn't this exactly what we just got done doing? Multiplication? So could you do it from here? All right, so all you have to remember is if you're dividing fractions, you keep, change, flip. Factor, 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 cancel, cancel, cancel. Okay. This one's already factored for you, nicely enough. So I know my x minus 2's cancel. What about my 4 minus x and my x minus 4? They're not the same, right? But I can cancel them. If I look at this piece right here, 4 minus x, if I pull out a GCF of -1, hold on, it looks like this. Is this the same as x minus 4? Yeah. So I can cancel these, but I have to throw a -1 up here. We will finish this up tomorrow, guys. Okay? Control S. Your homework tonight is page 3. I think there's 10 questions. Okay?